So today, I want to quickly cover the concept of state machines, and more specifically, we're going to look for a sequence of monkeys, because monkeys are awesome. So, in this case, I want to find a sequence of two monkeys in a row. And to find two monkeys in a row, how are we going to do this? So we have to have some sort of notion of a sequence or memory to be able to do that, or one type of memory. So let's go ahead and create some basic states over here. So I'm going to have our first state. I'm not going to write anything in this yet, but I'm going to say that this one is 0 monkeys seen. And then we'll have another state over here, which is going to be our 1 monkey scene. And then we'll have another state over here, which is going to be our 2 monkeys scene. Monkeys. So, how are we going to go between these states? Well, suppose I say that M equals, we see a monkey, and then likewise M bar means don't see a monkey. So let's go ahead and do our states over here real fast and go through this sequence. So suppose that this is our 0 monkeys scene. Well, if we don't see a monkey, there's no reason for us to go to any other state. We don't see a monkey. We stay in our 0 monkeys scene. However, if we do see a monkey, we should go and say, okay, now we've seen one. So we've got our monkey to be seen. If we see another monkey after we've just seen one, we should go to our 2 monkeys scene state. And if we keep seeing monkeys, we should stay in our scene at least 2 monkeys state, because that's really what this means now. We've seen at least 2 monkeys in a row. So they just keep monkey, 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 and so on. However, suppose we're in the 1 monkey scene state, and we don't see a monkey. Well, we can't have 2 in a row if we don't see a monkey. So we go back to the 0 monkey scene state in our bucket of 2. But if we're in the 2 monkey scene state, and we also get a non-monkey, then we should also go back to the 0 monkey scene state, technically. Because now we don't, here, let me go ahead and write this over here, M bar, because our sequence is only supposed to be 2 monkeys in a row. If, for instance, we get monkey, 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 and I'm assuming that our window is only 2 elements, so like 2 elements window, for instance. So I can only look at like these 2 elements at the same time, or these 2 elements at the same time, or these 2 elements at the same time. So that would be our sequence of 2 monkeys. So if I happen to get another sphere over here, give me one sec. So if I happen to get this sphere, then on this case, these 2 things would show that we don't have 2 monkeys in a row. We actually go back on whatever. But if I wanted to have another level of memory, like say it was a 3 element window, then this would no longer make sense over here. What the heck is happening there? Okay, so this part would no longer make sense. No, I don't want to delete all those. So let's go ahead and get rid of that part. If I had a 3 sequence window, so 1 monkey scene, and now I'm going to change this over to 3 element window, then we can also look at here, because we might have, now it's not going to worry about order. We're not saying we have 2 monkeys in a row, we see 3 monkeys in our window. But I said I wanted 2 monkeys in a row. So I'm going to go ahead and erase this and put it back into what I had before, which is our 2 element window. We want to see 2 monkeys directly in a row. So we'll go back over to here, and then I'll put the M bar for no monkey scene, and let's go through our states and verify it. So, in this case, we see 1 monkey. We start out, this will be our initial state. We see 1 monkey, we go into the one monkey scene state. We don't see a monkey, we go back. We don't have a monkey that we care about, like our state is basically invalid. Then we go to the next one. We see a monkey, we go back over to here. And we see another monkey, we go to here. And then we don't see a monkey. So there's no way that we can have two monkeys in a row now in our little sequence. So we go back all the way over to here. And then we get a monkey, we get a monkey, we get another monkey. And I showed it before, but over here there's the extra circle. So monkey, monkey, monkey. We've still been in this state for a while, and then we go back. And we get our output. Well, when we design these states, we want to have them have some sort of relevant output to basically denote whether we're in a specific state or not. And the way that we'll do that is I'm just going to go ahead and create a label what should I say for this? Let's say, I'm just going to do T for simplicity. T means we've seen our sequence. It's valid. Actually, no. Instead of T, I'm going to do V. V for valid sequence. So in this case, this is the only one that we have a truly valid sequence. So I'm going to say that this is our output. And over here, we have V bar. We haven't actually gotten our output yet. And then over here, we have V bar. We still haven't gotten an output. So if V equals to 1, then sequence detected. V equals 0, then no sequence detected. So 2 monkeys in a row not seen. 2 monkeys in a row not seen. So let's go ahead and go one step further. When we're designing the logic for these states, we need one other bit of information to tell whether... Whoa, that shouldn't happen. We need one other bit of information to tell, like, what state we're in. And that is going to be a state label. So what we'll need to do, in this case I'm actually going to zoom in, we need to assign a specific value, a unique value to each state to denote what state we're in. So in this case, since we have 3 states, how many bits do we need to represent these values? Well, the closest power of 2 is 4, so it would be like 2 to the 2 equals to 4. We know that we need 2 bits to represent these states, and we can do it with whatever way we want. In fact, actually, sometimes, depending on how you set up your numbers, the logic for these states gets minimized, but I'm going to be lazy. I'm just going to do it directly, and I'll just say that this is state 0, 0, this is state 0, 1, and this is state 1, 0. In other words, state 2, state 1, and state 0, which lines up with our monkeys scene. Nice and convenient. Well, that's really all I wanted to cover for today. I don't know why it's zooming in and out. It looks like my tablet's having issues. This is all I wanted to cover for today. These sequence detections and setting up these state machines, it's just a general concept, and I just use this as an example. But you can extend this to however many monkeys in a row that you want, or you can just say, I want to say in my window, I have a 5-element window. I want to see if I get 3 monkeys at all in that window. Well, you can create a state machine for that too. And you can also create state machines for things such as, let me go ahead and scroll down over here to get some space to write. You can do sequence detections for like traffic lights. Or not sequence detection, sorry. State machines for traffic lights. So a light goes green for so often, and then it goes yellow, red, and then it goes back to green. So you have those 3 states. Or you might also have a vending machine, which has states depending on what sort of coin you put in or $sign. Like, does it give you change? Is it supposed to vend a specific item? These state machines are built off of smaller state machines to help like guide them, and we can use these states to create our digital logic, which is something I'll cover in another video. As always, if you guys have any questions, feel free to comment below. If not, email me and I'll try to answer them as soon as I can. Thank you.